Welcome to the video on trigonometry functions and rules. So first we'll learn about sine, cosine, and tangent. So sine, cosine, and tangent are your basic trigonometry functions, and they use ratios to figure out angles or side lengths in a right triangle. So a way to remember your sine, cosine, and tangent is SO, CA, TOA. So your sine is your opposite over hypotenuse, that's your SO. Your cosine of theta is your adjacent over hypotenuse, that's your CA. And your tangent is your opposite over adjacent. Your cosecant is the reciprocal of sine, so it's 1 over sine. So it's your hypotenuse over your opposite. Your secant is 1 over cosine, so it's your hypotenuse over adjacent. And your cotangent is 1 over tangent, which is adjacent over opposite. You would think that cosine would go with cosecant, but it's actually sine that goes with cosecant and cosine that goes with secant. So you just have to remember that that's kind of weird. Then you have your inverse trigonometry functions where you solve for theta. So theta is your inverse sine of opposite over hypotenuse, and it's that same for each of the other functions. Theta will be the inverse of the trigonometric function. And then inside of your inverse, you would put whatever the ratio is, whether it's opposite over hypotenuse or adjacent over opposite or whatever it is. So we'll do some practice problems with this on the next slide. So this says find sine theta, cosine theta, tangent theta, theta, sine of beta, cosine of beta, tangent of beta, and beta. So we have theta first. So theta is this angle here. So first we need to find sine of theta. So our sine, if we think about our SO, our sine is going to be opposite over hypotenuse. So the side opposite of theta will be over here, so it's going to be 3 over our hypotenuse, which is this side here. So we need to figure out what that is. And we can use Pythagorean's theorem for that. So 3 squared plus 4 squared equals h squared. So 9 plus 16 equals h squared. 25 is h squared. So if we take the square root of both sides, we get that 5 equals h. So our hypotenuse is 5. So our sine of theta is 3/5. Cosine is CA. So that would be adjacent over hypotenuse, so 4 over 5. Our tangent is our TOA, so opposite over adjacent, so 3 over 4. So we can use any of these functions to find our theta if we do the inverse of this ratio. So our theta equals sine inverse of 3/5. It's also equal to cosine inverse of 4/5 and tangent inverse of 3/4. So you can find theta in degrees or radians depending on what mode your calculator is in. So in degrees, theta is approximately 36.87 degrees, and in radians, that would be 0.644 radians. So that's what theta is. For beta, our sine of beta is opposite over hypotenuse. So our opposite now is 4. So it would be 4 over 5. Our cosine is adjacent over hypotenuse, so 3 over 5. And our tangent is opposite over adjacent, so 4 over 3. So if you notice here, your cosine of theta is equal to your sine of beta, and your sine of theta is equal to your cosine of beta. And that's because your sine of 90 minus theta equals your cosine of theta. So since theta and beta add to 90 degrees, then our cosine and sine are going to be equal to each other. So then beta can equal sine inverse of 4/5, cosine inverse of 3/5 or tangent inverse of 4/3. So in degrees, theta will be approximately 53.13 degrees. And in radians, theta would be approximately 0.927 radians. So that's how you find your sine, cosine, and tangent, as well as your angles. So our sine rule is a rule that you'll use when you're given an angle and the side opposite to it, as well as an additional angle or side. So A over sine A equals B over sine B equals C over sine C. And you could also write that as sine of A over A equals sine B over B equals sine C over C. One thing I like to do is if I'm solving for a side, I'll use the formula this way. And if I'm solving for an angle, I'll use the second formula. It just makes the math easier. So if we were given that A was 30 degrees and A was 10, and then that C is 40 degrees, we could figure out what side length C is by saying A over sine A, so 10 over sine 30 equals C, which we don't know, over sine C, so over sine of 40. So to solve for C, we'd multiply both sides by sine 40. So C equals 10 sine 40 over sine 30, which is approximately 12.86 units. So that would be your side length C. And then you could easily find angle B by taking 180 minus 30 minus 40, because the sum of the angles will be 180. So that means angle B is 110 degrees. And then you could do the same thing with angle B to figure out side B. And that's how you would solve for all the sides and angles in the triangle. Next, you have your cosine rule, which you'll use when given two sides and the angle in between, or if you're given all three sides. So C squared equals A squared plus B squared minus 2AB cosine of C. So if we were given all of the sides, for example, so if this was 12, 10, and 15, we could find an angle using the law of cosines. So if we wanted to solve for angle C, for example, we could plug in all of our values. So C squared, 12 squared equals A squared, which is 10 squared, plus B squared, 15 squared, minus 2AB cosine C. So you want to make sure that your cosine of whatever angle matches what's on the other side of your equation. So we get 144 equals 100 plus 225 minus 300 cosine C. So 144 equals 325 cosine minus 300 cosine C. We'd subtract 325 from both sides to get negative 181 equals negative 300 cosine C. Then we'd divide both sides by negative 300. So we'd have 181 over 300 equals cosine of C. And then to solve for C, we need to take the inverse cosine of both sides. So our inverse cosine of 181 over 300 is equal to our angle C. This could be reduced, but you're just going to plug it into a calculator anyway, and you'll find out that C is approximately 53 degrees. So that's what this angle would be. And then you could use the law of cosines to find your other angles, or since you have an angle and the side opposite of it, you could also switch to using law of sines to find angle B or angle A. And then 180 minus the two angles you have would give the final angle. Finally, we have the equation for the area of a triangle using trigonometry. So you use this when trying to find the area of a triangle, and two sides with an angle in between are easier to solve for then the base and the height. So your area will equal 1/2 AB sine C. So if A was 10 and B was 15 and C was 50 degrees, we could find the area of the triangle using 1/2 AB sine of 50. So your area would be approximately 57.45 units squared. So this is a lot easier than trying to figure out what this height would be here and doing 1/2 base times height. So that's how you find your area. So here we have our first IB practice question, and the calculator is allowed. It says find the missing side and angles. So we're given two sides and an angle in between. So we don't have any sides across from an angle, so we need to go to our law of cosines. Since A is the angle that we have, we'll have the side A squared equals B squared, so 18 squared, plus C squared, 10 squared, minus 2 times B times C times the cosine of angle A, so times the cosine of 20 degrees. So since the calculator is allowed, we don't need to go through all the work of simplifying this. We can just plug this all in the calculator. So we'll get that A squared is approximately 85.7. So A is approximately 9.258. So now that we have angle A and side A, we can switch to using the law of sines. And we're going to solve for angle B. So angle B is across from our largest side. So this angle needs to be our largest angle. So we'll use sine on the top because we're solving for an angle. So we have sine of 20 over 9.258 equals sine of B, because we don't know B, over 18, because that's our side B. We'll multiply both sides by 18, and then we'll take the inverse sine of both sides. So we get that B equals the inverse sine of 18 sine 20 over 9.258. So that means that B is approximately 41.68 degrees. We know this can't be the case, however, because our angle B needs to be our largest angle. So we need to find the other B value where this would be true, and that's going to be where B is 180 minus this 41.68. Because those are the 2 points where our sine is going to be the same. Because if you look in a circle, your sine is your y value. So it's going to be the same here and over here. So at 41 degrees, and then also at 180 minus that 41 degrees. So our B value that we're going to use is approximately 138.32 degrees. So now that we have two angles, we can find our angle C by taking 180 minus 20 degrees and minus our 138.32 degrees. So C will be approximately 21.68 degrees. So now we've solved our triangle. So here we have our second IB practice question, which is also calculator allowed. It says a triangular town has one corner at the bakery, 4.8, one corner at a grocery store, -1, -2, and the last corner at the restaurant, 12.3. A, draw a picture of the town and label the distances and angles between the locations. So we have our X and Y axes, and we'll label our X up to 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and down to -1. And then we'll label our y-axis from -2 up to 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have the bakery at 4.8. So 4, 8. This here is our bakery. We have our grocery store at -1, -2. So that's the grocery store. And the last corner is at the restaurant at 12, 3. So here's our restaurant. So our town is shaped like this triangle right here. So we need to find the distances and angles between the locations. So we can find the distances using the distance formula. So the distance of BR is going to equal the square root of the difference of our x's. So it'll be 12 minus 4 squared plus the difference of our y's squared. So it'll be 3 minus 8 squared. So the square root of 8 squared plus -5 squared, which is the square root of 64 plus 25. So that's the square root of 89. So that's the length of this side right here. Now we can find BG. And I'll write the work over here. So BG equals the square root of -1 minus 4 squared plus -2 minus 8 squared. So that's the square root of -5 squared plus -10 squared. So that'll be the square root of 25 plus 100, which is the square root of 125. 125 is 25 times 5, so you can pull out a 5 and leave in the root 5. So that's BG, which is 5 root 5. And then we can find GR, which is the square root of 12 minus -1 squared plus 3 minus -2 squared. So that's the square root of 13 squared plus 5 squared, which equals the square root of 169 plus 25, which equals the square root of 194. So this side is the square root of 194. So now that we have all the sides, we can find an angle using the law of cosines. So we'll start with angle G. So using our law of cosines to find angle G, we get that the square root of 89 squared equals 5 root 5 squared plus the square root of 194 squared minus 2 times 5 root 5 times the square root of 194 times your cosine of angle G. So 89 equals 125 plus 194 minus 10 root 970 times the cosine G. So if we solve for G, we get that G equals the inverse cosine of 89 minus 125 minus 194 over -10 root 970. And we don't need to simplify that because we can just plug it into the calculator and get that G is approximately 42.4 degrees. Now that we have an angle opposite of a side that we know, we can use the law of sines to solve for angle R. So we have sine of 42.4 over root 89 equals sine of R, which we don't know, over 5 root 5. We'll multiply both sides by 5 root 5 and take the inverse sine of both sides to get that R equals the inverse sine of 5 root 5 times the sine of 42.4 over the square root of 89. So R is approximately 53.0 degrees. So then we can find angle B by taking 180 and subtracting our other two angles. So that gives us that B is approximately 84.6 degrees. So there is the picture of the town. And then part B asks, what is the area of the town if 1 unit is equal to 1 mile? So we'll label the sides of our town in miles because we know that the units are miles now. So our area equals 1/2 AB sine C, where C is the angle in between A and B. So we'll use angle R just because it's an even 53 degrees. So our area will be 1/2 square root 89 square root 194 times the sine of 53. So our area is approximately 52.47 miles squared. So we have the picture of our town and the area of our town. So in summary, we have several important equations for this chapter. We have our trigonometric and inverse trig functions. We have our sine rule, our cosine rule, and our area of a triangle. So all of these formulas will be included in the notes so that you can go back and refer to them and work on memorizing them for your test. That's all for this video. Thank you so much for watching.